Hey everyone, good evening. So we'll be just waiting for 1 more minute and then we will start. All right, let's get started. So we have started a discussion on pig. Right, we have seen where pig has been used. So just a quick summary: pig was introduced by Yahoo. Okay, because Yahoo uses this Hadoop for storing and processing their data, and the researchers there, they didn't wanted to spend time on writing Java MapReduce codes. So what they did is they introduced an abstraction layer where they are not actually coding in Java or Python, and this abstraction layer is basically giving them a, a powerful feature of writing scripts for processing their data. And this scripting language which Yahoo has introduced is pig. So pig works. So pig has its own language called as pig Latin, and it is basically a data structure driven kind of a language. So we had discussed in pig, whenever you will be coding, there will always be a left hand side and a right hand side. Okay, how a pig code basically looks like at a very high level. So I would be defining some variables. Let's say, for example, a equal to something, and I'll be doing some processing here. Let's say I load a file. In my next step, I would be processing this A. In my next step, I would be processing this B. So what you're basically doing, how this pig Latin looks like is, it is a data flow kind of a programming language, wherein you're wherein every step is basically a transformation. So if you notice, the first step you're loading a file, correct, which gives you an output A. In the next step, you're transforming A, right? You're transforming A to produce B. In the next step, you're transforming B to produce C. So basically, it's a data flow kind of a language. Let's say C is your final output. Okay, so you can just print C or anything. Okay. Now we have also seen about the data types in pig. Okay, so we had discussed about complex data types. So the first complex data type is called as a tuple. Now what is a tuple? So anything which comes inside a parenthesis, that's a round bracket, it's called as a tuple, and it can contain any number of fields. So this is an example of tuple which contains 4 fields. Now these fields are also called as atoms. Okay, these fields are also called as atoms. So it can be called as an atom or a field. Now inside a tuple, these atoms can be of any data type. So if you see the first data type, so first 2 are integers, third is a string, fourth is a float. So tuple can contain any type of data, any type of field. You can consider a tuple to be a row in your database. So let's say I have a table in my database. You can consider a tuple to be the rows of that. The next thing we discussed about a complex data type is a bag. Now whatever which comes inside a curly braces, that's a bag. right? What a bag contains? A bag contains multiple tuples. Now these tuples can contain any number of fields. Okay, now this is a bag which contains 3 elements, to be specific 3 tuples. The first tuple contains 1 atom, second tuple contains 2 atoms, and third contains 2 atoms. The next data type which we saw in pig was a map. So Chaitanya has a question, so bag can be a table. Yes, Chaitanya, so bag can be a table. Okay, you can consider bag to be a table and the tuples inside that to be the rows of that table. All right, now the next thing we discussed was a map. So map is basically a key value pair, just like a Java map. Anything coming in square brackets is a map. So it's basically a key value pair. So you define a key and the value is defined in this way. So the key and value is separated by a pound character. Now these were the complex data types which we saw in PIC. Now the primitive data types are, so you have integer, long, float, double. Then you have char array and byte array. So there is very limited set of data types available in PIC. So there is no string. So string is basically a char array. All right. Now just one thing, this is there in the next slide also. If you're defining a map, so map is very rarely used. So I would say it is only 1% cases map can be used. Most used is a tuple and a bag. So tuple and a bag, I will say it is 100% used. Every time, every pig code which you will be writing, you would be definitely using tuple and a bag. Map, it is most likely that you will never use a map. Okay, this particular data type is never used. Okay, so Minesh says, do you have a use case for map as an example? Yes, Minesh. So remember, like last time we saw a join example where we were joining population of a state with the actual state name. So what we were doing is the abbreviation of a state and the actual name of that state, we were storing it inside a map in case of a distributed cache example, right? So if you want to do that in pig, you can convert that particular file to be a map inside your pig. So it's basically the same use case where you would be using it in Java, right? So in Java, let's say you want to fetch some values based on a particular key, the same use case can be implemented here using maps. Okay, just an additional thing, whenever you are using map in pig, it's a mandatory thing that maps key should always be a string. Okay, maps key can always be a string. The values can be of any type. When I say any type, it can be any of these. Okay, it's just a mandatory thing. So to be specific in terms of pig, it should be a char array, right? There is no string in pig. It should be a char array. So same things are defined here. So every data type is defined here. Just one additional thing. So the bag which we discussed in pig, there are 2 types of bag. Okay, there are 2 types of bag. One is called as an inner bag and one is called as an outer bag. Now what is the difference? Basically it's the same thing, multiple tuples. It's the same thing, having multiple tuples. That's a definition of a bag. The only difference between inner bag and an outer bag is outer bag does not has a curly braces. Outer bag does not contains curly braces, inner bag contains curly braces. That's the only difference between a bag inner bag and an outer bag. Now let me tell you where this is used, why they have defined two types of bags. So remember I've said your pig language looks something like this. Always remember, so there's right hand sides, right? Basically what your actual processing statements would be. The right hand sides are called as transformations. And the left hand sides are called as relations. So to put it inside a statement, you can say every transformation inside a pig results into a relation. Okay, every transformation results into a relation. Now this relation, which is your left hand side, the data type of this relation, it's a bag. It's a bag without curly braces. So it's basically multiple tuples. A typical example, just to make it clear. Let's say I have a file which has 10 rows, 10 lines. I want to process this file. So what I would be doing is, let's say this file name is file.txt. So in the first statement, what I'll be doing is I'll be loading this file. This is a syntax of actual pig syntax. I will say load. I will give the path of this file. That's it. Okay. Now this left hand side, what it would be? Basically, so this left hand side, which is A, this is a relation for sure. This relation will contain 10 tuples. So the left hand side, okay, so A would look like this. And so on. So it won't have a curly bracket, but it would be tuples and a collection of tuples. And we have already discussed collection of tuples is called as a bag. But a relation does not have a curly braces. That's why it is a bag with a special handling. That's why the concept of inner and outer bags. Any doubts in this? Great. Okay. Now fields, which are also called as atoms, are assigned data types with the help of schema. Now when we are discussing about tuple, so let's say this is a tuple, or let's say I have a file. Let's take a real example. Let's say I have a file which contains employee data. It contains employee ID, it contains department ID, it contains, let's say, gender, it contains address, and it contains, let's say, email ID. So I have a file in this way. I have created a table on top of this file. Correct? Now, when we are dealing with pig, we are not talking in terms of tables. We are just talking in terms of files. Now, let's say this contains thousands of records. Let's take an example of simply 2 records. So I would be having an employee ID 1, department ID 10, gender, address is, let's say, here, email ID is, let's say, I have an employee ID 2, department, let's say 30, so female, let's say US. Now when I want to process this file, let's say I want to calculate how many number of males or how many number of females, any type of processing. If I wanted to do in pig, what I will be doing is the first step is always loading the file. It is always loading a file. So I'll say load and I'll give the path of this file. What this will result me in? This will result me in tuples. Correct? The A, the left hand side is basically a relation. So this would result me in 2 tuples. So this would be my first tuple and this would be my second tuple. Now, when you're defining a tuple, see, when we are dealing in terms of a database, okay, when we consider this particular file to be a table, what we usually do, we define a schema, right? Now, what is a schema? It's basically we are defining the field names and a data type. Okay, so Abhila says, where are we loading this data into? So this data can be anywhere, Abhilash. It can be on HDFS, it can be on local, or it can be on any Hadoop supported file system. For example, S3, FTP, anywhere. Okay, for our use case, let's consider this is on HDFS. Okay, now when we are thinking this file in terms of a table, what we usually do when we are defining a table, we are defining a schema. Now, what do you mean by schema? Basically, you define that my first field is an employee ID and the data type is an integer. My second field is department ID. Data type is again an integer. So you're basically defining field names and field data types. This is nothing but a schema. Now in Pig, okay, in Pig also, so remember when we talked about a tuple, we defined a tuple as a row inside a database table, correct? Now a row can have an associated schema, correct? So basically you can provide schema to a tuple. You can provide schema to a tuple. Now the best thing with Pig is Pig can work with structured data, unstructured data, and semi-structured data, basically all types of data. Now if I'm dealing with structured or in some unstructured data, there is no fixed schema, correct? So that's why Pig has an option, okay? So Pig basically says that defining a schema is optional. Okay, defining a schema is optional. Let's say I want to process this file. I want to calculate how many number of mails are there. Right? I want to calculate how many number of mails are there. What I would be doing is I want to access this third field, correct? Because that's the gender field. Now, if I define a schema, I can define that first field is employee, second is department ID, third is gender. If I define a schema, I can access the third field with the schema name. But if I don't define a schema, so defining schemas in Pig is optional. If I don't define a schema, then the only way to access this particular gender field is based on positions. Okay, it is based on positions. So this first position is 0, second position is 1, third position is 2, and so on. Okay, so let's say I want to apply a filter where gender equal to male. This is only possible if I define a schema. If I define that this gender is what is my third column. But if I don't define it, it would be this way. Now what is $2? So basically it's a positional notation. So 2 is actually the position of that particular field and you access that field using a dollar. So this is what I mean by defining a schema in Pig is optional. Any doubts in this? Okay, so Bhaskar says, can you please explain how to define schema here? So Bhaskar, defining a schema looks like this. So when you load a file, you have to say as, and you can define a schema. So the typical Pig syntax is employee ID, you have to give a colon int, department ID colon int. So this is how I define a schema. Okay, so everyone is very close. I mean, they're asking exact questions. So Minesh says, where do you define if the file is delimited? Okay, very good question, Minesh. Good catch. So what we do is, so in Pig, there is a default delimiter. The default delimiter in Pig is a tab character. Okay, default delimiter in pig, it's a tab character, \t. My file is a comma delimited file. Now, how do I define that my file is comma delimited? So I say using, there is an internal class called as pig storage. This is how I define my delimiter. So I say load this path using pig storage. So your pig will consider that your file is delimited by a comma, and as this part is optional. Yeah, that answers your question, Minesh? Okay. No, for tab, so Minesh says for tab just space. No, tab is a character. It is defined by \t. Okay, so if it's a tab delimited, you have to specify it this way, \t. This is a default thing. Okay, so Chaitanya says for tab delimited file, we should not specify pig storage. So Chaitanya, so if it is by default tab delimited, so this part also becomes optional. You can define it or you can skip it. Okay, so Shiv Prasad has a question. How do we know the position in multiple files and fields? So Shiv, if you're dealing with structured data, so it's an overall agenda. It's an overall funda in using MapReduce and Hadoop. So when you're defining your processing, you should know your data, right? You should know that this particular column is what, this particular column is what. Okay, so you should always know that this particular field is gender. So based on that, you will start counting from 0 to that particular field. Okay, so this is what the slide explains. So fields are assigned data types with the help of schemas. Now, additionally, so when you're defining a schema, what you're doing, you're defining two things. First, you're defining a column name. Second, you're defining a data type. Now, when I say defining a schema is optional, okay, defining a schema is optional. So if you don't define a schema, column names becomes the positional notations. What about the data type? The data type defaults to byte array. Okay, so if you don't define a schema, everything would be considered as a byte array. Now, why byte array? Because ultimately everything can be converted to bytes. So ultimately it would be a serialized format, correct? So either it can be an integer, float, long, double, char array, anything. Everything can be converted to bytes. That's why the default data type becomes bytes. This is case when you don't define a schema. If you define a schema, you can define data types. So fields are assigned data types with the help of schemas. For example, in relation B, age is converted to integer because 5 is integer. So if you look at this example, so they are loading a file and it has two fields, name and age. Okay, and this is basically a pig statement. If I want to loop through my file, okay, there is a loop, there's a syntax available in pig for each a. So when I say every relation is transformed, right? This is when what is meant by transformation. I will just use a pointer. Okay, so this right hand side, so this would transform A into B. Now what you're doing is, for every row inside your A, you're generating some values, and what you're doing, you're adding a number to this age. So if a schema is defined as a part of load statement, the load function tries to assign the given schema. But if, okay, now the best part is, so this is always in case of your big data tools. So we are discussing pig, correct? But whenever we'll start with other tools also like Hive, Spark, anything and everything in your entire Hadoop world, this is not tied to schema. Okay, when I said it's not tied to schema, this means let's say I have this particular file and I have defined my gender to be an integer. Okay, I have defined my gender to be an integer. Ideally, it's a string. Tell me one thing. If I do this in my normal database, okay, if I use, let's say MySQL, or if I say, let's say I use Oracle, I have defined a particular column to be an integer and I'm putting strings. Will it accept data? Yes. So Chaitanya Shrees, everyone says it would be an SQL error. Okay, it will fail with non-numeric value. Now, this particular design of your database, okay, this is referred to as schema on write. Okay, now what is schema on write? Basically, whenever you are putting some data inside your database table, every field is compared with your schema. If it conforms to the schema, it will accept the data. If not, it will start throwing in SQL exception. So this particular design is called as schema on write. While writing, it is checking. That's why writing inside a database, for example, Oracle or MySQL, let's say you're writing a huge data inside a traditional database, writing is very slow. Okay, writing is very slow because let's say I am inserting 1 million records. Every record inside that 1 million would be checked against the schema. It would be verified against the schema. That's why it takes time. On the other hand, okay, all your big data environment tools, let's say this situation occurs in your Hive or let's say in Pig. Let's say I have a huge 10 GB file. Out of that 10 GB, let's say it contains around 1 billion records. Out of that 1 billion, one row is not conforming to the schema. Okay, one row. Your database will accept it? No. Correct? Because it is a schema on write approach. Will your Pig accept it? What do you think? Pig or Hive or Spark, anything. Will it accept it? So the question is, out of 1 billion rows, one particular row is not conforming to the schema. So Abhilash says it should. Okay, the right answer is, okay, so Shiv Prasad says it won't. Okay, she says he thinks yes. Okay, so Shiv Prasad, see, I said I have a 1 billion file and one row is not conforming to the schema. Correct? If it is not conforming, now we are dealing with data, right? We are dealing with data from social networks. We are dealing with data from actual live streaming data sources. Correct? There is a possibility of some rows could be an error rows. If it starts throwing errors, I would never be able to process that file, right? That 10 GB worth file, I would never be able to process. If I want to process it, I should remove that erroneous row. Imagine how difficult it is to open a 10 GB file and delete one row. You would never be able to open a 10 GB file. That's why all your big data environment tools, may it be anything, okay, it follows an approach called as schema on read. Now, what is the schema on read? How it is different from the approach schema on write? So what schema on read will do is, when you're placing data, it will never check if it conforms to schema or not. It will simply put it, right? It will simply put it. When it will check the data type is when you try to read the data, when you try to access the data. Correct? So let's say I've put a file I've defined this as char array itself, the original structure, but while placing it, I've placed an integer. Okay, this case will work actually because char array can accept integer. This works in database also. So let's say I won't change this case. I would change this case. So my second field, department ID, it was expecting it to be an integer, but it got a dummy value. It got a string value. So what your pig will do, or Hive will do, or any big data tool will do, it will accept the data. It will write the data. But when you will start querying, when you will start accessing the data, at this row, it will then check if it conforms to the schema or not. And what do you think while reading? Will it give an error? Should it give an error? So while reading, it is not able to conform to the schema. So she says, no, it won't give an error. Abhilash says it will ignore that record. So you are following the right directions. So if it starts giving error, it's again the same case, right? I won't be able to process that file. So it won't start giving error. It will simply mark that particular field which is not conforming to the schema as null. Okay, it will just mark that as null. Okay, that entire row won't be ignored. The entire row won't be ignored. A particular field which is not conforming to the schema, that would be ignored. Okay, so Chaitanya says, what is the size restriction? So Chaitanya, size restriction in terms of what? Okay, int will have 4 bytes. Yeah, it's same like it's. So pig is also developed from, it's written in Java. So it follows the same restrictions as your Java. Okay, so Rahul says not getting, what do you mean by write? So when I say write, Rahul, it's basically inserting data, right? So what you do in a database, you define a table, okay, and you insert data, right? That is what I mean by write. It's insertion of data. Okay, Rahul says pig has database. No, so it is not a database. It is not a table. Okay, but if your file is structured, you can consider that file as a table. This is not the case always because pig works with unstructured data also. Okay, but if your data is structured and if you want that, you want to write some query, some filtering logic, some clauses. Okay, in this case, see, ultimately everything would be tuples. So you can define a schema and you can access each and every field. So it is ultimately not a database, correct? It is, but you can consider this to be a table. So you can just imagine this to be a table. In actual case, it is not. Okay. So this is what this statement says. However, if the data does not conform to the given schema, pig will generate a null value or an error. Now let's see when that error would be. So your data errors will never be there. But when you're trying to process that particular field with a wrong value, for example, you're adding a particular integer to a char array. In such cases, it will give an error. But when you're simply reading it, let's say if I'm, for example, if you consider in terms of your database, when I'm doing a select star, okay, while reading, only reading, it will never throw errors. But that erroneous field, if I am trying to process something on that, for example, I'm trying to add an integer to a char array, in such cases, it will give an error. Typecasting errors. Because ultimately, it is processing in Java because your pig is written in Java. So Java cannot add string to an integer, correct? So same issues you will find here. So for the same statement, this is just an example input. It has one row, let's say 4 and edureka. Name is 4, age is edureka. So if you see, What is a schema? Schema is name and age, correct? And I'm loading integer. I'm loading the data other way around. The first field it is expecting to be a char array, but it's an actually integer. Second field it is expecting to be an integer, but it is actually a char array as per my schema. When I print this, for printing this, the statement is called as dump. When I print this, my output would be 4 comma nothing. Now why 4 got printed? 4 I am defining it as a char array. Okay, char array can basically take anything, right? You can, this is same like your database. You can convert your integers to a string. Okay, so 4 would be considered as a string and printed. Edureka, it cannot be considered as an integer, right? So it will give null. Right? Getting this? Any issues with this? Okay. Now, so Bhaskar says, won't it error? No, Bhaskar, it won't, because it's a schema on read approach. If I'm trying to basically add something to this age, then it will error, because I cannot add something to edureka. I cannot add something to string, then it will error. But while simply reading it, it will never error. Okay, so however, it is mandatory to assign schema always, since if we don't assign data types, default type is byte array, and implicit conversions are applied to fields depending on context in which field is being used. So same thing I mentioned, right? A default, if you don't define schema, the default data type would be a byte array. So in case explicit cast is not supported, now what is the case of errors? Okay, when you will start getting error in Pig. So these are two examples. So I'm loading a file, okay, with a char array and integer, and for everything I'm trying to typecast char array to an int. Right? I'm trying to convert my character, basically my string, to an integer. The rows where it would be able to do it, it will print that. Where it is not able to do it, it will start giving error. Right? So when you're so the same thing, when you're reading a file, that's a schema on read approach. Okay, does not conforms to the schema. Okay, null. No error, but it will put null. But when you're trying to process that particular field, it will start giving errors. Right? So if Pig cannot resolve incompatible types through implicit cast, Pig will report an error. Another case, you cannot add char array and float. So let's say I'm loading a file with two fields, name and age, with the schema being char array and float respectively, and I'm trying to add up these. Right? My Java does not support adding a name, adding a string and an integer, right? It will give an error. Okay, so Bhaskar says Pig will only support flat files like CSV. What about audio, video, image, etc.? So Bhaskar, Pig will actually load that file. If you are having some special kind of processing, you can do it on audio, video files also. But it is always, it is not a good practice to use Pig for audio and video and images files. Pig is not designed for that. Right? So this is a typical case where you should not use Pig. Okay, so Minesh has a question. Can we do in Pig read first 2 or 10 rows just to see data? Yes, Minesh, we can. Right, so let's say my data is very huge, it contains 2 billion records. I just want to check if the data is loaded properly or not. What I will do, I'll simply see first 5 or first 10 records. So I can do that. I can put a limit to the number of rows to be outputted. I can check that. Okay. Same thing happens in Hive. Right, so the things which we have discussed, let's read that. So a field is a place of data. It's a piece of data. So the field is nothing but an atom. All right. So this is a field. This is a field. This is a field. Okay, every field inside a tuple, okay, or that's also called as an atom. So we are talking about that. A field is a piece of data. This can be treated as a column in a table in database. Fields are accessed by positional indexes or by name. So if you define a schema by name, if you don't define a schema by positional indexes. Positional indexes is generated by the system. So these positions are basically given by your pig. You don't define it, right? So pig by default assigns positions. Positional indexes is indicated with the dollar sign and starts from 0. Like $0 would be the first column, $1 would be the second column, and so on. Names to the fields are assigned by the user when defining schema with pig storage or any loader or internally by the system during some operations like group by. So the same thing which we discussed, like if you want to give a schema, you can give a name. Right? There are some operations in pig in which pig by default uses a name in case of a schema. Right? So what we have discussed is pig will by default use a positional notation like $0, $1, $2, but there are a few cases where pig will also use a name. And the typical use case is when you use a group by. Okay, so let's say I'm grouping by gender. Let's say I group by gender in this case. So what will happen is the key on which you're grouping, that is the gender, right? Pig will automatically give this field a name, and the name would be group. Okay, so what is group? This is a magical word which is given by pig itself, and this is for what? This is in some operation. So if you're doing group by, so on the key which you're grouping, that particular key is given a name as group. The field name would be group. Okay. Okay, so it also is on multiple. If you're doing group by is on multiple, so the combination of that field would be group. Right? And will work as combinations. So just an example. So if a first field is character and second field is an integer, you can access through positions $0, $1 or names, name and age. Right? And possible values could be these. Okay, so what is a tuple? A tuple is an ordered set of fields. Tuple contains fields which may be of different data types. So we have discussed these. A tuple can be compared to a row in your SQL with fields as columns. Since tuples are ordered, we can access fields in each tuple using indexes, that is $0, $1, and so on. Tuple constants use parentheses to define tuple and commas to separate different fields. So this is a tuple. The first field is an char array, second field is an integer. You can assign a schema to it, or you can use positional notations. This would be $0, this would be $1. The above declares a tuple constant with two fields of data type, char array and int respectively. So if you look at this particular pig syntax, so I'm loading this file, and for each data I'm generating $0. Okay, what do you think what this statement will print? Yes. So Rahul says first column, she says Edureka. Yes, just the first column. Yes, Manish. It would be just the first column. All right. So it will print Edureka. Right. So notice this example doesn't have a schema. Hence we can reference individual fields in the tuple by their positions. A tuple is enclosed in parentheses, as we have seen. In case if we have relation defined with schema, we can access the field using field names. So let's say you're defining a schema also. So in the first case, there was no schema. Here I'm defining a schema. So instead of using for each data generate name, so initially I was using it as $0. So if I have schema, it is very simple for me to access the fields. So when you're using a structured file, always try to assign a schema. It will simplify your life. Because in the preceding statements, you won't have to keep in mind what was the position of that particular field. If you're assigning the schema in the first statement itself, it becomes very simple for you to use it in the preceding statements. Okay, the next data type in Pig is bag. Again, guys, I'm again reiterating these data types, tuple, bag, map, and this fields, and the things which we are discussing now. If you get this everything, Pig is done. Okay, Pig is very simple then, right? In terms of syntax, there is not much syntax used in Pig. If you talk in terms of operators available in Pig, for example, group by, filter, the things which we saw for each generate, these are very few. The list is very small. So comparatively, using Pig is very simple. Once you get what data types and how Pig is using these data structures, right? Your Pig is very simple. Rahul says, tuple can contain a bag. Yes, Rahul, tuple can contain a bag. Okay, this if I want to show it in terms of a statement. Can anyone tell me, is this a tuple or a bag? Okay, so Rahul, everyone says tuple. Sanip says it's a bag. Okay, no, Sanip, it's not a bag. It's starting with a parenthesis, right? Round brackets. So it's a tuple. How many field this tuple contains? Okay, Shiv Prasad has a question. But bag must contain tuple. Yes, yes, Shiv Prasad. Bag must contain tuple, but tuple can also contain a bag. So the thing which I have written. Okay, so how many fields are there inside this tuple? Okay, so Manish says 6, Abhilash says 6, others, everyone says 4. Okay, so Manish and Abhilash, the right answer is 4. So if you see the fields, the first field which this tuple contains, the first field is a bag. This is the first field. Second field is an integer. Third field is an integer. Fourth field is an integer. Getting this? So the first field is a bag, right? This is what I meant by a bag. A tuple can also contain a bag. See, definitely bag will contain tuples only, but an entire bag I can put inside a tuple. So Rahul says for bag data type is char array. So Rahul, if it's a bag, it's not a data type for the entire bag. It's the data types for the tuples which are there inside that bag. I cannot define a data type for a bag. I can define data type for tuples only. Right? I can define data types for tuples only. So this bag won't contain any data type, but the tuples inside this bag will contain the data type, and the data type would be integer for every case. So Manish says it can be treated as one-to-many relation in a bag. As in, I didn't get your question, Manish. One-to-many in terms of what? Yeah. So Manish says like instead of repeating values, show it inside the bag. Yeah, you can consider it to be one-to-many in that case. All right. So what is a bag? It's a collection of tuples. Inner bag is enclosed in curly braces, right? As I've mentioned, there are two types of bags, inner and outer. Inner bag is enclosed inside curly braces. Tuples in bag correspond to a rows in a table. So you can consider a bag like a table. If you just want to compare with a database, you can consider bag to be a table and the tuples inside that bag to be the rows of that table. Right? Some few properties about a bag. A bag can have duplicate tuples. So this example can be this way also. I can have duplicate tuples inside this bag. So if you will be noticing, when we are talking in terms of big data, there is not much restriction on the data. Because if you're dealing in a big data environment, if you're dealing with the huge volume, and remember, big data has a property called as veracity. When I say veracity, that means inconsistent data. So I want to process inconsistent data also. That's why there is no additional limitations on data. Okay, for example, if your data is duplicate, if your data has some missing rows, some missing fields, still your tools would be able to process that data. Okay, so Minesh says, how do you define the table structure in this case? So basically, Minesh, you are defining structure only for tuples. All right, you don't define a table structure for a bag. You can just consider a bag to be a table, but you're not defining a structure of a bag. All right, I can have a bag containing multiple tuples of different fields also. So basically defining a structure for a tuple. All right, this can also be a case. Okay, so if you see this bag, this contains three tuples. First tuple with one element, second tuple with two, third tuple with many. Okay, so this is also possible. Okay, so Shiv Prasad says, so you mean to say, first we have to define tuple, then after we have to define a bag. Okay, so why this concept of bag is stepping in? So let me tell you that. So when you're dealing with a file, as I mentioned, first step is always loading a table, loading a file. So when you're loading a file, at that time you're defining a schema. And when I'm loading a file, my left-hand side, when I'm loading a file, my left-hand side is always tuples, right? Okay, my left-hand side is always tuples. Multiple tuples, I agree. It would be multiple tuples. That's basically an outer bag. Correct? So the only control you have to define schema is when you load the data. You cannot define the schema later. All right, and you cannot load a bag. You can just load a file, which will ultimately result into tuples. Correct? So you're not loading a bag. You're dealing with only tuples. Now, why this bag data type? So when you're doing some operations on your tuples, okay. So when I'm doing some operations on this A, it will result into bag. So your pig's implicit operations results into bag. Okay, for example, if I'm doing a group by on A, it will result into a bag. Right, so getting this, Shiv, you're not defining a bag at the first place. You're defining a tuple only. Why? When a bag is formed, when you're doing some operations. And when you're doing some operations using your pig operators, at that time you don't have control to define schema. You have control to define schema only at the first place when you're loading data. That's it. Is it clear, Shiv Prasad, or there is still confusion? Okay, not clear. All right. So what will happen is, so when I'm loading a file, okay, let's say my file has 10, or let's in this case 4 rows. These are the 4 rows inside a file. When I'm loading this file, when I want to use this file in Pig, my first step will always be load this file. Every time. Okay, every time my first Pig statement would be load. So what I'll be doing is I'll be loading this file using Pig storage, and I'll be specifying comma and everything. Right? It will result into a relation. All right. Now this relation, what it would be? It would be multiple tuples. Right? It would be multiple tuples. So this is what will come inside as an output. Right? This would what will come as an output when I try to print this A. Right? Now what is this? What is the structure of this? Data type of this? Yeah. So Shiv says it's a tuple. All right. Now I agree it's a tuple. Okay. But these are multiple tuples, right? How many tuples are there? 4 tuples are there. Correct? Why 4? Because my file contains 4 lines. So every line, every row would be a tuple. Okay, that's why we are calling this as an outer bag. Okay, but ultimately it's a tuple, multiple tuples. Don't get confused between outer bag and inner bag. Consider this to be multiple tuples. All right. This is the only place where I can define schema. Okay, how I can define schema? I can define as column 1 as int, column 2 as int. Right? So you agree I have defined a schema? Great. So this is the only control which I have for defining a schema. All right. So my first step, my first statement of Pig would always be load data, and only that point I'm defining a schema. And my load data would always return in tuples. Okay, my load data will always return me tuples. It will not return me a inner bag. It will not return me something like this curly braces thing. It will not return me that. All right. Now, when this is converted to bag, when I'm doing some operations, let's say I do a group by on column 1. Right. So the intermediate data type of this particular tuples would have a bag. Okay. So not only group by, there are multiple statements. If you're doing a join and everything, union, everything basically will have some bags in their operators. So basically bags are coming when you're processing it. Correct? So you cannot define a data type for a bag. You can just define it for a tuple, and you cannot load a bag. Getting it? You're not loading a bag directly. You're loading a file which is considered to be multiple tuples. You're not loading a file inside a bag directly. Like, getting it? Okay, this will become more clear when we'll actually see an example. Because Rahul says if I load A to B, that time it becomes bag. No, Rahul, if I'm loading A to B directly, then also it does not becomes a bag. There are few operators in Pig, just for example, group by, which will result me a bag. See, ultimately, all my left-hand sides, always remember this, all my left-hand sides have to be tuples. My left-hand sides, which are called as relations, it will always be tuples. Okay, when I say tuples, it would be multiple tuples. Okay, in other terms, outer bag, but don't get confused. It would be multiple tuples, right? When I'm using a group by also, still it would be a tuple, but that tuple will contain a bag. The thing which I had shown here, this thing, this way. The structure would be in this way. My tuple contains a bag. Okay, so Rahul Shiv, I understand there is still some confusion, all right? When we'll see an example, you'll get a clear idea. All right. So bag is a collection of tuples. Inner bag is enclosed in curly braces. Tuples in the bag corresponding to rows in table. Okay, so bag properties. Bag can have duplicate tuples. A bag can consist tuples with different number of fields. However, if pig tries to access a field that does not exist in any tuple, then a null would be substituted in the empty index. This example. So if this is a bag, right, I want to print the third element of every bag. Sorry, I want to print the third element of every tuple inside that bag. Right? So my first tuple would result me in null. Second tuple will result me in null. Third tuple will print 1. Right? So if it's not able to find that particular index, it will print null. It will substitute null. That is what the statement says. If it tries to access a field that does not exist in any tuple, the value null is substituted in that empty index. A bag can have multiple tuples with fields with varying data types. Right? So all these data types can be different. So I can have a tuple this way. Right? This is also possible. So my bag is containing tuples and the data types are varying. Right? Number of fields are also varying, data types are also varying. Right? So this is possible. However, for pig to effectively process bags, the schema of the tuples within those bags should be same. Now I cannot do much productive type of processing on such types, right? Because every field has varying data types, every field has varying number of fields, every tuple has varying number of fields. I cannot do some productive processing in such cases, right? But if you're considering structured data, so all these tuples would contain equal number of fields, right? And the data types would also be same. So in such cases, I can process. So that is what the statement says. To effectively process, the schemas within those bags should be the same. Okay, just an example. If half of the tuples include char array fields, while the other half include float fields, only half of the tuples will participate in any kind of computation because the char array fields would be converted to null. Let's say I'm doing some addition of a number to a number. All right. So if it's a char array, I cannot do it. Right? Just an example. Bag have two forms, outer and inner. Outer bags are the relations which we have in pig, the left-hand sides. Right? So outer bags, a relation in a bag or of tuples, also known as outer bags. A pig relation is similar to a table in relational database. Right? So when I'm talking about relation, that's the left-hand side I'm talking about. Right? Just an example, this example. So I'm loading, I'll just use a spotlight. Yeah. So if I'm loading a file as name and age, okay. So this is basically, I'm just printing that file. Right? This is basically my relation. My X is a relation. Right? And this relation basically are tuples, but as they are multiple tuples, it is called as an outer bag. right? So a relation is a outer bag. Pig relations don't require that every tuple contain the same number of fields or that the fields in the same positions have the same type. It totally depends on my file. Okay, if the file I am loading, the first row contains, let's say 10 delimited values, second row contains, let's say 2 delimited values. All right. So this statement says it does not require that every tuple contains the same number of fields or that the fields in the same position have the same type. Oops, Shiv Prasad says we are not able to hear you. Is it true for everyone? So I'll just, okay, Shiv. So he just lost for 2 minutes. Okay, okay, Shiv. Yeah. So the same thing which we have discussed already. Pig relation don't require the tuple contain the same number of fields or that the fields in the same position. It totally depends on the file which you are loading. Relations are unordered, which means there is no guarantee that tuples are processed in the same particular order. Okay. So let's say I have a 1 GB file, okay, which contains that employee data. All right. Ultimately, Pig would be processing it as a map reduce job, right? So these 1 GB file which I would be having would ultimately processed in terms of input splits. So this 1 GB would have 8 input splits. Correct? If my Pig is processing it, basically my map reduce is processing it, how many mappers will run? There would be 8 mappers. Can I guarantee that the sequence of my mappers, the sequence in which my mappers are created, they would finish at the same times in the same sequence? Can I guarantee that? Yes, everyone says no. The reason for being no is my mappers are running parallelly, correct? I have multiple machines. My mappers are running parallelly. Any machine can finish your mapper first, correct? So my 8 mappers, let's say my 4th mapper finishes first, then my 2nd, then my 6th, then my 7th. It can be in any sequence, all right? That is what is meant by this statement. Relations are unordered, which means there is no guarantee that tuples are processed in any particular order. It totally depends on the input splits your Pig is creating and which mapper finishes first. Okay, so this part we have discussed, the below part. So inner bag, so here you go. This is an example of group by. Okay, so Shiv Prasad, this will solve your doubt. Okay, and Rahul, yours also. So inner bag, so now suppose we group relation A by the first field to form a relation X. So if you notice, when I'm loading a file, I'm not populating a bag. I'm populating tuples only. Okay, I'm populating tuples only. Now when the bag is formed, when we're doing some operations, as I have mentioned earlier. Now let's consider an operation to be a group by operation. Okay, so what I'm doing is, suppose we group relation A by 2 fields, by the first field to form relation X. So take this example. I say group A by age. Now what this is forming, is this a tuple or a bag? What is my final output? Tuple or bag? Okay, so everyone says tuple. Shri says it's a bag. Okay, so remember Shri, as I mentioned, all your relations, right? All your relations will every time be tuple. Okay, tuple as in multiple tuples. So if you see, this is a tuple, right? This is a tuple of, okay, now only Shri will answer. So tell me how many fields are there inside this tuple? So she says 3. Okay, now she says 2. Correct? So the right answer is 2. So the first field is an integer, second field is a bag. Correct? The first field is an integer, second field is a bag. All right? And this bag, did we populate the bag? No. Pig created a bag. And why it created? Because we did some operation. Right? Again, not every operation creates a bag, just few. For example, group by. Group by creates a bag. All right? Now if you see, now what it has done, okay, what it has done is, it has basically grouped all the rows together which contains the same age. That's my grouping key. Correct? So let's say I'm grouping by age. So the age became my first field, 25, and all the tuples which belong to 25 was formed in a bag. Okay, my second field, my age was 45. All the tuples which has the age as 45 came inside a bag. So this is what pig does in group by. Any doubts in this particular structure? This is very important, right? The group by thing is very important. If you understand this, it's very simple then. I mean, overall it's very simple. Okay, so Rahul says it's clear. I hope it's clear for everyone. So in group by, what it is doing, all the tuples which belong to the grouping key comes in a single row. And when it comes in a single row, it comes in a form of a bag. Abhilash says it's like between 25 and 45. No, Abhilash, it's not between 25 and 45. It means that my file contained only two ages, 25 and 45. So it's not a between operation. It's a group operation. So all the tuples which has the age 25 would be grouped together. Okay, okay. All right, Abhilash. So the question was before that statement. Yeah. I think due to some network issue, it came late to me. All right. Okay, so the next thing is map. So again, to tell you, map is very rarely used. Okay, just to, I mean, you should know what is a map. It's very simple. It's just like a Java map. All right. A map is a set of key value pairs. A map is a char array to data element mapping, which is expressed in key value pairs. So it says it's a char array to data element. So that is what I mentioned. There's a mandatory thing in a map that your maps key should always be char array. Your pig cannot accept a key to be another data type other than char array. Okay, so if you're defining a map, the key would always be string, always be char array. Value can be of any type. Okay, value can be of any type. It can be string, integer, long, float, double, anything. It can be a bag, tuple, anything it can be. But the key should always be a char array. It's a mandatory thing in pig. So basically what you're doing, you're mapping your data to char array. That is what the statement says. It's a char array to data element mapping, which is expressed in key value pairs. The key should always be of type char array and can be used as index to access the associated value. It is not necessary that all the values in a map be of the same type. Again, so we're dealing with veracity of data as we're dealing with big data. So the values type can be anything, but the key type should be char array. Okay, and inner bag is enclosed by curly brackets. So this statement should be there in the previous slide. It's a wrong position. It's not here. Okay. Key value pairs are separated by a pound with comma separating keys and values. So this is what a key value pairs look like. This is what a maps look like. Key value separated by pound. So if you notice in this example there are two key values inside this one map. both the keys are char array, but the first value is char array, second value is an integer. So Chaitanya says, will any of the operations generate map? No, map is a special case, Chaitanya. Okay, map is generated by your data. Okay, this is there in the next slide. Okay, so map is what are maps used for? It is basically used for lookups. If you want to look up a particular value quickly, you define a map. Okay, so maps are created by us. Right, so that's there in the next slide. So in order to load data from files as map, the data should be structured as below. So basically, when you're defining a map, okay, when you want to populate a map, your file should contain data in a square brackets itself. Okay, so this is your actual text file, which is containing your data in your square brackets itself. Right? This is the reason Pig's map is used very rarely. It is used only in those places where you want to define a lookup. Okay, you cannot create a map from any data file. Let's say if I am considering my employee data, I cannot create a map of my employee data. If I want to create a map of my employee data, what I would need to do, I would need to open the file. I would need to convert my file in this format. I would need to append a square bracket, key and a value with a pound character. That's a huge overhead. Yes, Rahul. So Rahul says data should have a pound. Yes, it should have. Okay, so your data should have square brackets also. It should have pounds, this pound also. Okay, that's why it is very rarely used. It's only used, the typical use case of a map is if you want to do a lookup. Okay, same example, if you're taking an example of your state's abbreviation and your population. So abbreviation part I can put inside a map and I can refer that map. So it's basically a lookup kind of a thing. But actual data file you would not load it as a map. That's why map is not much used. Yes, Rahul. So Rahul says, I thought it's good to read JSON array, but now we can't. Yeah, with maps we cannot. So this is how a map is loaded. Okay, load a file as the data type is map. All right. For each map, generate this keys values. You can filter, you can do anything, and dump. Okay. So again, rarely it would be used. Okay, the load statement will construct two maps. Okay, this we can skip. It's okay. The operators in Pig, right? So as I mentioned, there are very few operators in Pig, right? So the syntactically, there is nothing much in Pig. The operators are very less, but the operators which are there, though it is less, these are very powerful. Right? Most of your logic, all right, can be obtained in such few operators also. The operators are very powerful. The transformations which you can do on your data are much richer. Okay, so for loading and storing, you have operators load, store, dump. For filtering, you can use filter, distinct. For each, generate is a loop. Okay, stream. Okay, this is fine. Grouping and joining, you have join, co-group, group cross. Sorting, you have order limit. You have union split. So these are all operators in Pig. The list is very small. Okay, that's it. It's only this much. Nothing out of this. Okay, so Rahul says any operations for date. So Rahul, these are operators for dealing with your file, but for dealing with your data, right? You have lots of operators. Okay, so basically talking about functions. You're not talking about operators. So functions, yes, there are lots of functions. You have, for example, this group by. That's a function. Right, so you have functions for working with dates, timestamps, strings. You have functions for these inbuilt functions. Okay, so this we have already discussed the concept of nulls. So data can contain null. So in pig, data of any type can be null, right? When you say it is null, that means the value is unknown. So this is an example. Okay, so in your file, let's say your file is containing data in this way. So what I've done is I have a file which basically contains sorry, 5 elements. The fourth element is missing. But when I will be loading this file, I would be specifying my delimiter as comma. So your pig will notice that between these two commas there is no data. So this is a case of null. So pig won't throw any error. Pig will handle it in this way. It will just show a blank there, blank or a null there. Okay. So data at any field in your file can be null. Okay, it can be of any data type. Right? There is no data. So your strings, your char array can be null, your integer can be null, floats can be null, anything. Okay. Now for loading data, so there are multiple file loaders available, right? So, okay, so Chaitanya says, will output be stored in files? Okay, so let me discuss this. Okay, this will trigger some more discussion. All right, so let's discuss. So when I say every relation in pig, sorry, when I say every statement in pig is a transformation. So let's say a equal to, I'm writing a pseudo code for a pig Latin. So let's say load file. Yeah, Shiv. So Shiv says file is file name. Yes, and just use this way. Okay, it's just a pseudo code. It's not a actual pig code. It's not syntactically it's not right, but it's just a pseudo code, just to show you the flow. Okay. Now what I'm doing here. So if you notice, my flow is a little bit complex. In the first case, I'm loading a file and I'm storing that to a relation A. I'll just use a highlighter. Okay, I'm loading a file, storing it in a relation A. I'm filtering my relation A based on some filters. I haven't applied any filter here, but let's say I'm filtering it, which results into B. Then I'm loading a third file. Sorry, I'm loading a second file. And then I'm joining my first B with C. So it would be this. My join would be on B and C. Okay, after filtering, what is the output? That I'm joining with my another file. All right, and in my final output, I'm doing some filtering on D. So I'm defining an algorithm. I'm defining my processing logic here. Okay, and ultimately my final output is coming inside this E. Okay, now what I can do with my final output? So I can do two things. Okay, listen to this carefully. I can do two things. Either I can print my output, or I can store my output to a file. Okay, so Chaitanya, this will answer your question. So I can either print my output or I can store my output. If I want to print it, I will use the syntax dump. If I want to store it, I will use the syntax this. Okay, so what dump will do, it will display the output on the console. Store will store it into a, tell me, it would be a file or a folder? Can anyone tell me this would be a file or a folder? Very good. So Rahul says folder. Abhilash, you say file. Okay. So it would be a folder. The reason is ultimately pig is triggering a MapReduce. MapReduce always generates folders as output. So this would be a folder. Okay, so Minesh says, how about write to a table in a database? So that we can do, Minesh, using Scoop. Pig cannot write directly to a Oracle database or a Pig or a MySQL database. It will create files, and that files I can use Scoop to transfer it to a actual database. Okay. Now, very important thing, guys. It is there in the coming slides also, but very important thing. Okay, so Chaitanya says, is it HDFS path? Yes, Chaitanya, it is HDFS path, or it can be any file system path, and which your Hadoop supports, right? It can be S3, HDFS, local, anything. But ultimately, it would be a folder, and that folder will contain part files. It can be either part M or part R, depends on your logic. Okay. Okay. Now what I'm doing here is I'm defining a very complex logic. So let's say in my first statement, I'm loading a file. Okay. When it sees the second statement, when it's filtering my first relation, do you think it will trigger it there and there itself or later? So when I'm writing my second statement, do you think it will execute then and then itself, or it would be just compiled and not executed? Yeah, so Shiv Prasad says it will just compile. Everyone says it just compile, right? That's the right answer. So every statement is just compiled. Okay, my third statement, it just compiles it. So what your pig does, okay, so ultimately pig is going to create MapReduce. Now, if my logic is very complex, it is a possibility that your pig will create multiple MapReduces. Okay, if your logic is very complex, your pig can create, let's say, 5 MapReduces also. So my first MapReduce output would be fed to the second. It all depends how your pigs want to process it. Okay. Now, what your pig does, ideally, it creates an execution plan. Okay, your pig creates an execution plan. When it looks at the first statement, it will create a plan. When I say it compiles, what it is doing in compilation phase, it will create a plan for the statement, add it to basically it will create a plan for that statement. When it looks at the second statement, it will create a plan added to the program plan. So there are two types of plans. You can say there's a program plan, there's a statement plan. So what it does, for every statement it creates a plan, adds it to the overall program plan. So it looks at the first statement, creates a plan, add to program plan. Second statement creates a plan, add to program plan. So for every statement, it just creates plan. Okay, so until this statement, nothing is executed. The trigger point for pig to start execution is only these two operators, dump or store. When it will see this dump or when it will see this store, that is the time when it will compile. Okay, when it will convert, not compile, it will convert your program plan to a physical plan. When I say physical plan, that's nothing but a MapReduce plan. So when it sees dump or when it says store, that is the time when it will convert your plan to a MapReduce plan and then it will execute. Okay, because it does not make any sense, correct, to start execution until my whole flow is defined. right? So the trigger point is dump or store. All right. Now the files which you are loading, right? Pig supports multiple types of files. It can be a text file, binary file, multiple types. So it has multiple types of file loaders. Right? You have a bin storage that's used for binary file. Right? When you're that is usually in terms of your audio, video, zipped files, that case. Right? Pig storage, it is anything which is coming delimited, comma delimited, tab delimited, dollar delimited. Any delimited file can be loaded using pig storage. Okay, similarly you have text loaders, CSV loaders, XML loaders. There are different types of loaders available. Mostly we would be using pig storage, because if you see CSV loader, we can load a CSV file using pig storage also if we specify a delimiter to be comma. So everything ideally can be converted to pig storage. Okay, so Shiv Prasad says, can we have a break? So let's have a break. Let's have a 5-minute break. Okay, logical break. So I would be available in case you have any questions you can discuss. So I would just put a timer. Okay, so Minesh says last week you were planning to send all the scripts in email. Can you send it? Minesh, actually I have not collected everything inside a single place at a single place. Some of it is on my local, some of it is on my VM. I will collect it and send it soon. Okay, so one thing I need to discuss with everyone. So I know this is the last weekend as per the actual plan. Okay, but we would require extra classes also. And I'm not, so my overall strategy is to cover everything. And I don't want to skip things. I don't want to run everything fast, right? My motto is to make everyone understand everything. So this may take another 2 or 3 days also. That's my worry. Okay, so when I say 2 days, that's the entire the next weekend. I would try to cover everything, but if it goes one more day extra, okay, so would that be fine with everyone? Okay, thank you guys. Thanks for your support. So everyone says yes. Great. Okay, so Chaitanya has a question for Pig to run resource manager and node manager should be up. Yes, Chaitanya. Okay, so there are two ways, right? So in the last session we discussed that Pig has two modes of execution. It can work on MapReduce also, it can work on local also. Okay, so if when you're running in local mode, you don't require Hadoop at all. Okay, so how would you achieve that? So just to open a slide. Yes, Chaitanya. So if you can see, in local mode, I can start Pig with Pig minus X local. Okay, so for this, it does not require Hadoop at all. When I say does not require Hadoop, it does not require resource manager, no node manager, no HDFS, no MapReduce, nothing. Okay, so understand Pig to be a language. Okay, Pig is actually a language. Okay, the execution can be anything. It can run. The only advantage of Pig is it can run on Hadoop and it can run on local. right, so if you have any other questions, you can just put it. I will just go and grab some water. All right, so let's continue. So this is the group by operation, right? This is the group by operation which we saw in the case of the earlier thing, right? The age one. So the same thing. Let's have a look with the data. Okay, so I have a file which contains this rows. So it has 1, 2, 3, 4, 5 rows. Okay, I've loaded this file using a comma, and this has resulted me into a relation, right? So what I've done is I'm loading a file using pick storage comma, and I've defined a schema, and I'm dumping A. Right now, what I'm doing is I'm grouping A by name. Right, I'm grouping A by name. If you notice clearly, in the second row, when it is Sam, the age is missing. Still, it will work. Right? See, there is no errors. It will still work. Right? Now, when I group by name, what will happen? So all the fields, all the tuples which have the same name comes as a single row. Right? Would be grouped together. That is what is meant by group by. So if you notice my output, so it's again a tuple. My first field is my grouping key. That's Joe. Okay, basically name. Joe is repeated twice, correct? So what happens is these two will form a bag. If you look up at Sam, there is no other row like Sam. So Sam is just coming once. Okay, similar for John and Angel. Okay, so in group by, what it does, it basically creates a bag of all the tuples which belong to that particular key. Right, I'll repeat the statement. In group by, your pig groups all the tuples and creates a bag, okay, for all the tuples which belong to that particular key. Right? Now, what is a co-group operation? Okay, so Rahul says if key is null, in that case also bag will create. Yes, so any time when you're saying group by, it will create a bag of tuples. Even if the key is null, so that particular thing would be, so it would be this way. Okay, so let's say out of these, my 3 fields are null. Okay, so I would be having a null here and a bag of 3 nulls. Okay. Now, can anyone tell me what is co-group? Like if you have an experience in SQL and all, you must be knowing what is co-group. So let me tell you, co-group is nothing but join. Okay. She says having, no. Co-group is nothing but join. All right. So what is a? So I'll tell you what is co-group. See, with an example, it would be better to understand. So I'm loading 2 files. First file contains name, age, and GPA. That's basically grading. First file contains name and GPA. Second file contains name and roll number. Okay, this is a syntax for co-group. The same syntax is used for joins in Pig also. So I say co-group A by name and B by name. So I'm joining these 2 files by name. Okay, the output which it has given is very similar to how it looks for group. That's what it is called as co-group. So what it has done, so if you look at the first field, first output, what do you, so it's a tuple. Okay, how many fields are there inside the first tuple? Okay, so Rahul says 4, remaining everyone says 3. So Rahul, if you look at it carefully, it is 3. Okay, the first is the thing on which you are doing a co-group, in our case name. Second is a bag, third is a bag. So there are 3. Okay, now second bag is what? Second bag is coming from the first file. Sorry, so this second field is the first bag. The first bag is coming from the first file, second bag is coming from the second file. Okay, so what group was doing? Group was basically referring to a file and the fields inside a file. What co-group does, it basically joins 2 files and brings it in a single row. That's the only difference between group and co-group. All right, co-group can join 2 files. Okay, if you look at for Sam, same thing. Okay, it created 2 bags. The first bag would be from the first file, that is your student. Second bag would be from the second file, which is your student role. Yeah, so Bhaskar says structure of these files are different. Yes, Bhaskar, structure of these files are different. That's the reason the tuples which you see inside these 2 bags are different. So in the first bag, tuples has 3 fields. And the fields are basically name, age, and GPA. Right? See, Joe has name Joe, age 18, GPA 2.5. But when it comes to the second bag, it contains 2 fields, and the 2 fields are name and roll number. Okay, so the 2 files contains different types of fields, but when you're joining it, when there is the same operator, it's just yes. So Bhaskar says it's just like 2 tables join. Yes, exactly it is. It is just like a 2 tables join. Okay, and you're joining it on the basis of name because this 2 files name is a common thing. Okay, now let's say I want to join these 2. I want to join these 2 files. Okay, isn't what I'm doing it now? If I'm using a co-group operation, it's joining it. It's joining, right? So when I'm using a co-group operation, it's joining the 2 files. I'm passing on which basis it needs to join. I'm passing it needs to join on the basis of a name. right? Your pig also has something as a join operator. So it has a co-group operator, it has a join operator. What do you think? What should be the difference between co-group and join? Okay, so Rahul says one bag in join. Okay. Shiv Prasad says co-group is kind of similar data type. No, Shiv Prasad, it's a different data type, right? See, joining, when you're joining on a particular key, in case of name, in our case, name year. So data type should be same. So either you're doing a co-group or a join, data type should be same. Okay, so let me tell you what is the difference. Logically, there is no difference. Okay, co-group is same like join. There is no difference. Okay, the only difference is the data structure. Okay, the only difference is the data structure. So if you look at this case, my first case had 2 bags. Okay, if I flat this, okay, basically if I, so there is an operation in pig called as flatten. Okay, what flatten does? Flatten converts, basically it removes bags. Okay, flatten will remove bags. When I say remove bags, if you look at the first example, it will remove this curly braces. Right, so how, so in my first, how my first row will look like, how my first relation will look like, it will look like 1 2 3 4 5 1 2 3 4 5 tuples. Okay, that is what exactly happens in join. Okay, join, what it does the same thing as co-group, but that's a flattened structure. So let me show you an example. Okay, so I have 2 files. Okay, in the first file, that's my data 1, I have 3 fields, A1, A2, A3, everything integer. In my second file, I have, which is my data 2, I have 2 fields, B1, B2, both are integer. Okay, this is the structure of my file. Okay, I'm joining both these files, let's say on the basis of join A by B, A1, B by B1. Okay, so this is A1 and this is B1. I'll just use a highlighter. Okay, so I'm joining my A from this first field A1. I'm joining my file B on this first field B1. If you look at the output, I can do the same thing using a co-group also, right? Okay, the only difference is what you will see in your output. In your output, there is no bag. The structure is a flattened structure. Okay, the structure is a flattened structure. That's the difference between join and co-group. Right? That's the difference between join and co-group. Your co-group creates bags, but your join will basically flatten it. Yeah, that's the only difference. So just read it. So Rahul says always full join. Yeah, so it supports different types of joins also, Rahul. It supports outer joins also, inner, outer, left, right, everything. Okay, so join and co-group operators perform similar functions. Join creates a flat set of output records, while co-group creates a nested set of output records. That's the only difference. Okay, this is a union operation. Just like your normal SQL, I have 2 different files. I don't want to join it, I want to union it. So let's say I have a table which contains 10 rows. I have another table which contains 20 rows. When I union, my final output would be 30 rows. Okay, there is no logic. It's just union, as the name says. Merge the contents, right? Same thing happens with your pig. So if in the first case I have a file data which contains 2 columns. My second file has again 2 columns. When I say join, it will basically add. So my first file has 2, second file has 3, my final file has 5. Okay, so Kishore says, does it remove duplicates like union SQL? No, Kishore, it does not. It simply adds it up. Now let's come to pig. So these were about operators. Okay. Now what are the functions which you can use in pig? For example, this group is a function. Okay. So there are lots of functions, right? You have functions to deal with load, store, mathematical functions, string functions, date type functions, right? So there are lots of built-in functions, right? The best part with pig and hive also, okay, it is that let's say you have to perform a typical operation for which there is no function available. Okay, the best part in pig is you can create your own function, you can write your own function, you can code your own function. Ideally you can change everything in pig. See, pig is written in Java. All right, you can extend any class and you can override the methods, you can change the functionality. So pig is extensible. Okay, when I say extensible, you can inherit from any class and change the functionality as it is written in Java. All right, so you can change the way pig evaluates, you can change the way pig will store, pig will load, right? Everything is customizable. Yeah, Chaitanya says, so we should write Java code. Exactly, Chaitanya. So if you want to customize pig, that will only be in Java. Like in case of MapReduce, you can use any language. In case of pig, you cannot. You have to use Java. The best part with pig is pig can invoke any language. Let's say I have a Python script. All right, pig can call a Python script. Right, that's one additional thing in pig. It can call other languages. Okay, but the core implementation of pig, for example, if you want to do a core implementation of a user-defined function, it should be only Java. Right, so you can write your own functions that's called as UDF. Right, it stands for user-defined functions. Okay, I have to write it in Java. So the main difference, so these are all inbuilt functions. Main difference between built-in functions and pig UDF is built-in functions don't need to be registered because pig knows where they are. Okay, so these are pig's inbuilt function, so pig knows about it. But when you're writing a custom function, right? So ideally I'll tell you how to write it. You will write a Java code, convert it to a jar file. That jar file is your custom function. So whenever you want to use it, you have to register that jar file. Right? So that's the difference between your built-in and user-defined functions. Built-in functions don't need to be qualified when they are used because pig knows where to find them. Pig functions are case sensitive, right? And uppercase. Right? So most of the pig functions are uppercase. Not everything, but most of them. For example, min, max, count, all of these are uppercase. Okay, so Rahul says register means signed. No, Rahul. So register means, so when you will start a pig session, right? So when I'll enter into pig shell, you have to add that jar to pig. Okay, so I have a jar in which I have defined a UDF. Okay, I want to let my pig know that this jar contains my UDF. So I will add that jar, and to add it, there's a syntax called as register. Okay, and we have an example for this. Right, so the list is very huge. You have eval functions. Just an example: average, back to string, concatenate. You can count, count star, difference, is empty, min, max. So all of these. Okay, you have absolute. These all floor functions, mathematical functions. You have all of these. Okay, you have string functions to check ends with or equals ignore case, index to do lower, upper. Okay, you can regex, replace, everything. Date time functions, you can add duration, get current time, right? Get day, minute, everything. And you have functions to deal with tuple, bag, map. For example, you can convert between them, right? You can convert back to tuple. You can convert tuple to bag. You can convert to map. So these are some functions available, inbuilt functions available in pig. Right? So you must read this about the functions and your operators in pig. Right? So there are some utility commands. Okay, so I told you, right, for so there are two ways in which you can run pig, either using a shell, right, or writing your pig statements inside a text file. That's called as a pig script. So there are two ways. So whenever you are into shell, so there are multiple utility commands. These are simple shell commands: clear, execute, help, history, kill, quit, right? Your shell commands. Okay, now let's talk about joins in pig. Now there are specialized joins. See, when you are using pig, when you are joining in pig, it's not a normal SQL join. Ideally, you will be imagining it as a normal SQL join, but internally what it is, the internal architecture is different, right? Internally it is map reduce. So it will take advantage of the types of map reduce joins available. So remember, we have reduce side join, map side join. We had discussed this in the last module. Okay, so we had taken an example of your distributed cache. We had actually coded reduce and map side joins. Okay, so this is what basically is your pig can take advantage of your map reduce types of joins. So there are three joins available in pig: replicated joins, skewed joins, and merge joins. Okay. Now what are replicated joins? So replicated joins is equal to your map side join. Okay, replicated join is equal to your map side join. What is a map side join? So just to re-revise quickly, map side join, this can be only possible if one of the files is very small. So what you can do is you can put that small file inside a distributed cache and you can join from every mapper. Okay, you don't require a reducer in map side join. Okay, yes, Chaitanya, you have to put everything inside a distributed cache. So that small file becomes local to every node manager and my big file has a local lookup. So my join is happening at my map side. So in terms of pig, that's a replicated join. So it will replicate the small file across the nodes. And how it will replicate? By using a distributed cache. So pig will ultimately use your Hadoop, right? So it will use your distributed cache. It will use your Hadoop architecture internally, map side join. Now what are skewed joins? So let me give you an example, a quick example. So let's say I'm joining and I'm joining on the basis I have employee. So let's say I have two files or okay. So let's say I have two files. I have an item ID. I have an item. Okay. So let's say I have a outlet in which I'm selling some items, right? I have a table which contains which customer bought which item, right? So that's why I have a customer ID here. I have one more table which contains my customer information, customer ID, customer name, address, and let's say gender or something. Okay, so I have two tables. Now let's say one of my customer, okay, so let's say I have only two customers, customer ID 1, customer ID 2. All right, these two customers are buying a lot of things from my shop. And let's assume that customer 1 is very rich, right? He buys lots of things every day from my shop. All right, so let's say I have only two customers and this particular file, let's say this file is of size 10 or let's say 5 GB. Right? So my two customers buying so many things that my entire file became a 5 GB file. out of this 5 GB, let's consider, as my customer 1 is very rich, let's consider 4 GB belongs to my customer 1 and the remaining 1 GB belongs to my customer 2. Now when I will join, okay, when I want to join these two files, how will I join? On the basis of a customer ID. Now what will happen in this case, my customer ID, let's say customer ID 1. So from my this file 1 and from my this file 1, it will go to a same reducer. In terms of map reduce, if you're talking, the key is same. In our case 1. It will go to a same reducer, right? On the basis of the partitioning function. Everyone agrees? Yes. Okay. So what is happening here? So customer 1 is purchasing, the data for customer 1 is worth 4 GB. So imagine when my reducer is running, it's running on a single machine and all the mappers would be transferring 4 GB to that machine. Correct? 4 GB. So that network of that machine would be used for 4 GB, which will take time to transfer. Right? So this is what I mean by data is skewed. Skewed in terms of layman language, it's called as data is not distributed properly. Okay, there's an uneven distribution of data. So if you consider in this case, customer 1 has data worth 4 GB, customer 2 has data worth only 1 GB. So there's an uneven distribution. So with this uneven distribution, it's called as data skewness. With skewed data, your reducer will have a lot of load. Load in terms of network also, because that huge amount of data would be transferred to that reducer, and load in terms of processing also, because that reducer will be processing huge data. Okay, in our case, if there are two reducer 0 will process 4 GB, reducer 1 will process 1 GB. Okay, so there's a load on data. Now what pig can do in this case is, so if you're doing it in normal map reduce, if you're writing your own map reduce job in Java, controlling this skewness, it's very complicated. How can you control? Any idea how can you control this? So let me tell you how to control it. It's basically based on your statistical functions. Okay, what we can do is, for that 4 GB, as the key is 1, I can calculate something called as a histogram. Right? And based on histograms, okay, I can break that one key further into multiple elements. I can distribute it in my way itself. It's just a statistical logic. Same thing Pig has implemented. Implementing it yourself, it's very difficult. All right. Same thing Pig has already implemented. That is called as a skewed join. So what happens in skewed join is, if your data is not evenly distributed, if your data is skewed, you can specify Pig to use a skew join. In this case, for every key, Pig will calculate histogram and try to balance your keys across reducers to optimize your output. If it does not balance this, your output will still be there, but it will take a lot of time because your reducer will take a lot of time to process. Right? Now what are merge joins? This is also a good logic. What are merge joins? So let me tell you. This will come in Hive also. Okay, let's say I have two files. Okay, let's say I want to join, or let's take another example. I have employee ID, department ID, I have gender, I have salary. I have one more file which contains department ID and department name. So I have two files. I can join these two files on the basis of department ID. Okay, let's say the two files are very huge. If I want to optimize join, there is one way in MapReduce, or not exactly MapReduce, but there's a way in overall data flow. Okay, so let me come to Paint. So I have two files. my file 1, file 2. Okay. On this file, I'm running a mapper. On this file, I'm running a mapper. I have a reducer. This mapper sends the output to this reducer. This mapper sends the output to the reducer. My reducer gives me the final output. All right. So this is a data flow. Now what is happening here? So this is a reduce side join, right? A typical reduce side join. My join is happening at my reducer. This is unoptimized. The reason being shuffle and sort is happening twice. Shuffle and sort is the most expensive phase in your map reduce. So shuffle and sort happens twice. That's why this join is very slow. Now to make it fast, what I can do is, I know I would be joining on the basis of my department ID. Okay, so what I can do, I can pre-process my file. I can pre-process my file, and when I mean by pre-processing, what I can pre-process, I will pre-sort my file. And pre-sort on the basis of what? On the basis of your join key. In our case, department ID. All right. So what will happen with this pre-processing is, so for my file 1, if it is pre-processed, I will be having multiple sections. This is for department ID 1, department ID 2, department ID 3. From my file 2, when I'm sorting it on the basis of department ID, again I'll be having 3 sections, right? For this department ID 1, 2, and 3. When I want to join it on the department ID key, tell me what I will do now. I have pre-sorted my file. Tell me, can anyone think what is the advantage of doing it? So I have pre-processed my file. I have sorted my file based on my join key. What advantage I am getting? Okay, so processing quickly, Shiv Prasad says processing quickly, that's obvious. I mean, that's why we have this kind of join, right? So to improve the performance, but why, how? Okay, so Rahul gave a perfect answer. So Rahul says directly merge the output based on key, as the grouping is already done. Okay, so what we need to do is, if these are my 2 files sorted, what I will do, I will merge this first section with this section. I will merge the second section with the second section. I will merge the third section with this third section. Basically merging my sections of my 2 files. So this is called as merge join. The only thing to remember in merge join is your file should be sorted, and sorting pig will not do. You have to do it yourself. Okay, so Bhaskar says how it can guarantee that they will have same values. That again, Bhaskar, you should know your data while doing it. Okay, so you should know that when you're joining, these values are there. So let's say you have one more key, 4 year. Okay, but there is no 4 year, so it won't join. The only matching things it will join, remaining things it will ignore. So basically it's doing an inner join. Okay, if you want to do an outer joins also, that is also possible. I know this is not matching. I will just print this. I will not print this. So this is how your pig will know, because it knows the number of keys and number of keys in both the files, and then it will join. Does it solve your question, Bhaskar? Okay. So Bhaskar says, my question is, why the 3 file is 456? What's the advantage in sorting? I think there's a Can you just okay. Okay, so Bhaskar, if so your question is if the two files has no common keys, then you will never sort it. Why do you want to sort it? It will never join also. You cannot join these two files then. So may you use any type of join, it won't join. May you use a sorted join or sorry, a skewed join or a replicated join or a merge join, it will never join. Okay, so in such cases there is no need of sorting. Okay, so a common key will be there, but values may not be common. Oh, so Bhaskar, in my entire map reduce, everything happens on keys, right? My joining would be on keys. See, I'm not joining on my values, right? I'm joining only on my department ID. The remaining fields would be different. Doesn't matter. If the joining key is same, remaining values it will never check. It will simply join it. So this is true in every case. Okay, in any join it is true. Great. Right? And how do you say pig that I want to use a replicated, skewed, or a merge join? All right, Bhaskar, let's take it offline later. Okay, so how will you mention? So in join syntax itself, you can mention using replicated, skewed, or merged. You have to use this using field. So let's look at the syntax. Okay, so let's discuss. So we have already discussed. Let's read through it. So it is also called as fragment replicate join. Replicated join works on inner and left outer join, and it does not support right and full outer. The reason being, when you're doing a replicated join, you have to specify a small file, and the small file, how do you specify? It's based on the order of files. Rightmost file is the smallest file. Okay, so it will not do a right outer join, it can do a left outer join. That's how it is designed to do. Special type of join that works well if one or more relations are small enough to fit in the main memory. In such cases, PIC can perform a very efficient join because all of Hadoop work is done on the map side. This is on map side join. Replicated join can be used with more than two tables. In this case, rightmost table is read into the memory. Okay, means large relation comes first, followed by smaller relations. So there's a sequence when you join. There's a sequence when you specify the files. Pig run replicated join by loading the small file into distributed cache. That's the typical way. How do you proceed with map side join? Okay, so if this is an example. So how do you specify? You specify your syntax and you say using replicated. This will use a replicated join. If you talk about skewed joins, so it works for inner and outer. One of the keys is much more common than others, and the data for it is too large to fit in memory. This is what I was talking about. Data is not distributed properly. One of the key has lots more data than other keys. Okay, so standard joins run in parallel across different reducers by splitting key value across processes. So what will happen in skewness is there would be a load on a single reducer. So if there is a lot of data based on certain key, the data will not be distributed evenly across the reducer, and one of them may get stuck while processing. Right? Now how does skew join handle this cases? It calculates a histogram to check which key is most prevalent and then splits its data across different reducers for optimal performance. So though the key is common, still it will use multiple reducers for that, and for that it calculates a histogram. How do you specify using use a skew join? You have to specify using skewed after the join syntax. Merge joins. So in normal or default join, both input are sought first according to the join key and complete the join. So this is what your joining does, right? So if you're joining it normally, both input are sorted first because it happens in your sort and shuffle and sort phase. This is called your sort merge join. If both the files are already sorted based on the join key, then we don't need to sort it again. In this case, the merge join is very efficient. So only the case where your files are pre-sorted, your relations are pre-sorted, only then you can use the merge joins. It is very fast. To do merge join, two data sets are both sorted in ascending order by the join key. It is only supported in inner joins. Okay, so Bhaskar, so just one additional thing, your merge joins is only supported for inner joins. So when it is, in this case, when it is not matching, it will not join on the base of 4. This won't be joined. Okay, only this 1, 2, 3 from here and here will join. Uncommon keys will never join. Okay, that is what an inner join is. So work join works on MapReduce mode and okay, so merge join will only work when you're running in MapReduce mode. When you're running in local mode, it will be converted to regular joins. Of course, you're not, for MapReduce mode only, its sorting is required. Otherwise, it will not do a merge join. Even if you specify merge, it will do a regular join. This is how you specify using merged. Now pick UDFs. Right, so we have already discussed that you can create UDFs for those pieces which is not provided by pig directly. You can basically add your custom logic of processing and give it to pig. That's called as a user-defined function. So pig allows users to combine existing operators with your own code using UDF. The advantage of pig is its ability to let users combine its operators with their own or others' code via UDFs. Pig itself comes with some UDFs. A large number of standard string processing, math, complex types UDFs were added from version 0.8 onwards. Okay, just one additional thing, guys. So pig, though it is, pig was developed around 2009 and 10. So it's been almost 7 years. But pig is not very mature. So if you look at the latest version of pig, the latest version is still 0.12. So it is still 0 point something. So it is not very mature. Okay, you don't have a version 1 or version 2 of pig. Okay, so it's still in the very early phases of your functionalities. Okay, so over the period of time, there will be a lot of additional things. So the latest version of pig is 0.12, 0.12. Okay, now the best thing with pig is, so it's not about pig, it's about the Apache community. So what Apache community did is, it created lots of UDFs. So UDFs we can write on our own, right? You have to just open an Eclipse, you can write a UDF in Java. So there are lots of people who have already written some UDF. What Apache did, it basically collated all the UDFs from all the people, created a huge big jar, all right, and it is giving it out freely. Okay, so there are lots of, so if you talk about UDFs, you have lots of inbuilt UDFs. You can create your own UDFs and you can use others created UDFs also. Right, so what Apache did, it created a huge big jar. Okay, that jar is called as piggy bank. It's a very funny name. It's related to pig, so it's called as piggy bank. So what this piggy bank contains, it contains custom UDFs already written by existing users, right, by the Apache community people. So you can use that piggy bank also. How do you create a UDF? It's very simple. You can extend the UDF function and override the method and add your functionality. For example, if I'm doing a processing, I want to have a UDF, I want to check if my data which I have contains a age field. I want to check for specific ages, right? I want to check for specific ages, like if it's 18, 19, 21, 23 or 27. Okay, so I can write a UDF, let's say I've written a class is of age, which extends filter function, is basically a filter function. I will override the method exec. It's a fixed method, exec. All right. What I'm doing is I'm just converting this tuple. Okay, I'm converting my object. Where is my object? Yeah. So from what this tuple will contain, this tuple will contain multiple fields, right? I want to get the actual field, which is the age field. So my tuple can contain ID, name, age, and other things also, address. I want to get the actual field which gives me the age. How will I get that? I will say tuple dot get. When it says get 0, this means your file should have age as the first field. So it is getting the field which will give it age. It is converting it returns an integer. Returns an object, sorry. So it is converting it to an integer. It is just checking it and returning true or false. That's it. It's a normal simple if-else logic, comparison logic. Right? There's nothing very complicated here. Right? So what you do is you write a program in this way, convert this to a jar, right? And register that jar in your pig. It is very simple for creating UDF. Additional thing, your Hive also supports UDF. Hive also, you can create UDFs in Java and create a jar. How to call a UDF? So you have to register a UDF. So I can register my jar and now I can use it. Filter A by is of age and you can pass age to it. So this will return you. This will filter basically all of these which has your age mentioned. So this will filter all of the ages, which is 18, 19, 21, 23, and 27 based on this written logic. Is there anyone who did not understand this logic? It's a very simple if-else comparison logic. And this is a pretty standard way. Okay, so there's a filter. Okay, so Shiv Prasad says, can we modify existing UDF? No, Shiv Prasad, we cannot modify existing UDF. So basically, existing UDF, how they must have written it, they must have extended it from filter function already, and they have created a jar of it. So if you so for modifying that, you have to modify the entire pigs jar. Okay, so that is not right to do. Okay, so Minesh says, how do you execute pig script from Hadoop? So Minesh, there are two ways, right? You can, so it's there's a command pig. You have to install pig first, right? And it gives you a shell. Okay, from shell you can write your code, which all the codes which we were seeing, the pig statements. It will ultimately trigger on MapReduce. It will ultimately trigger on Hadoop. Okay. So there are lots of functions. There are evaluate functions, aggregate functions, filter functions, load store. These are all the functions. You just you must read these, go through these links, right? Okay. Now this is so as I mentioned earlier, right? If you have an existing script, right, may it be in Python or may it be a shell script or may it be a Ruby script, if you want to use Hadoop, okay, if you want to run that script distributed manner, you can use pig. All right. So what pig has a very excellent functionality. It can call your existing scripts from your pig shell, from your pig command. So it has an operator called as stream. So you can say stream, you can give a alias is your pig relation through, and you can pass a command. A typical example. Okay, let's say, so this head minus n5, this is a shell command. What it does is it will print the first 5 lines of your file. So what I'm doing, I'm loading a file. Okay, I want to print the top 5 records. So I say head minus n5, that's basically a shell script, it's not a pig statement. Okay, but I'm calling that shell script from pig using the stream. So I'm streaming these transactions through, and I'm giving a shell script here. This is not a pig statement, and I can print my top 5. It will actually trigger your shell script through pig, run it distributedly, and print your output. So this is a very excellent functionality, and this functionality is mostly used, it was basically created because, see, pig was developed by Yahoo, right? So in Yahoo, the researchers already had their scripts running. So they didn't wanted to basically migrate all their existing Python scripts to pig. So they created a module, they created a functionality in pig through which it can, without changing your existing Python scripts, they were able to run it through pig. They were able to integrate Python with pig. That's why this logic was created. This stream operator was created. It's a very good thing. Just one thing to remember, when you are giving the commands directly, you have to, this is not a single quote, this is a backtick. Okay, the key which is just below your escape button, the backtick character. Right, parameter substitution in pig. So let's say a typical use case, I have a script which runs daily, and daily my input files are changing. So will I create multiple scripts for every input file? No, right? What I can do is just my input file is changing, and of course as my input file is changing, I'm running it daily, my output file will also change. So I can make my script parameterized. I can pass a parameter as input, I can pass a parameter as output. Okay, so you can use parameter substitution in pig. Yeah, so Shiv Prasad says file name would be parameter. Yes, Shiv Prasad, file name would be parameter. Okay, now I can have a script which is very big. Let's say it has 10 parameters. Okay, so you can basically, how will you write, how will my pig know that it's a parameter? So again, you have to use a dollar symbol here. Now don't get confused. So dollar is used at multiple places in pig. First, dollar was used in your positional notation. Second, dollar is used in your parameters. So let's say you want to parameterize your input file. So I will say dollar input, and at runtime you will pass that value of that parameter input. Okay, this way. Right? So I have a file. This is my pig script. I have parameterized my input. So load, and this data path I have parameterized. I have made it $data. I would be passing this parameter at runtime. And how do you pass it? Pig minus param data equal to input. Okay, and what is this input? This input is this input file which you have. Okay, this path of your input. So this is how you can parameterize it. And how do you pass a parameter? Using this -param. Right? Let's say I have 1000 parameters. Okay, so how will I pass it? I'll say -param 1000 times. So my command to execute the script will become very huge, right? If my script is very huge, I have 1000 parameters. I cannot pass 1000 parameters at runtime using this command line. So what I can do here in this case is I can write the parameters in a file also. I can create a file of my parameters. And instead of passing the single parameter, I can pass my file altogether. Okay, in this way. So I can create a file, let's say my params, and I can define my parameters there. And while running it, I can pass the -param file option. Initially, I was passing the option -param. Now I can pass the option -param file. I can use param and param file both together also. In a single statement, I can pass param and param file both. Let's say there is a parameter which is defined in both the places, in the parameter file also and in your command line -param also. The one which comes at the last, that's the command line that takes the highest priority. All right. So this is about piggy bank, which I was talking about. Okay, so there's a jar, piggy bank jar already available, which contains lots of operators, UDFs written. You can just download it from your Apache's website and you can register and use it. Okay, this is just this is an example. I have a piggy bank jar. I can register that jar. So register and the path of my jar. I can use it directly. So if you see in the B statement, in this B, I'm using that jar directly. This is just a fully qualified method name I'm calling. Right? This is how you use UDFs. Okay, so Shiv Prasad says, can we copy that jar files? Yes, Shiv Prasad, you can. All right. Now there are some diagnostic operators also available in Pig. Yeah, so Chaitanya says register should be used for every session. Exactly. So when you're registering a jar, the lifetime of that jar is only until when your session is active. Your session is closed, your jar's lifespan is gone. Okay, if you want to use it multiple times, for every session you have to, the first statement should be register the jar. So if you're writing a pig script in a text file, the first statement would be register. Okay, the lifespan is just until the life of your session. Okay, now there are some diagnostic operators, for example, describe, explain, illustrate. Okay, remember I was saying for every statement, your pig creates a explain plan, and then ultimately, when it sees a dump or store, it creates a physical or map reduce plan. You can actually see what pig plan is. You can see the plan created by pig. How do you see it? Using the explain syntax. Okay, so let's say you define a very huge flow, A equal to something, then B equal to C equal to D equal to. Ultimately, instead of saying dump D, you can say explain D. It will open the explain plan of that. Okay, what is describe? This is just like your SQL describe. So if you define a schema, you can describe what is the schema is. You can describe a tuple, you can describe a relation to get the schema. And there are some additional statements register which we have seen in case of a jar. There's also define. You can create an alias for a UDF. Like in this case, if you see my UDF's name is very big, org.apache.pig.piggybank. The name is very big. I can give a shortcut name to this using define. I can define a shortcut name for that huge jar, huge UDF class name. Okay, so this is how a describe statement looks like. So if you see, I've loaded student using pig storage and I've defined a schema. And when I describe A, it displays the schema. So it says name is char array, age is int, GPA is float. So this is how describe is used. If you see the explain plan, so this is how your explain plan is. You can explain any operator, any relation basically. It will tell you how it would be going to execute your entire logic. Like, see, it's not a normal language. It's written in terms of pig itself. So you won't understand each and everything inside this explain plan, but you would be able to make out how it is planning, how many map reduces would be created. Okay, you would be able to get to that particular detail. You will not get each and every detail which is shown in this explain plan because it is very pig specific. All right. So use the explain operator to review the logical, physical, and map reduce execution plan that are used to compute the specified relationship. Logical plan shows a pipeline of operators to be executed to build the relation, type checking, and backend independent optimization. Okay, so I'll talk something about this optimization thing which your pig does. It's an additional thing not there in the slide. Let's say I'm writing a logic. I'm first loading a file. I'm writing a pseudocode. I'm filtering my data. Then I'm grouping my data. Okay, and this is my final output. My second flow is I'm loading my data. I'm grouping my data. And I'm filtering my data. Can anyone tell me, out of these two flows which I have written, which one is optimized? Out of these two flows, which one is optimized and which one is not? So Shri and Minesh says one is optimized. Chaitanya says two. Okay, Chaitanya says two is optimized as I'm grouping. So Chaitanya, if you see, and I'm grouping in both the cases, one and two both. That's the sequence I'm changing. Abhilash also says two. Okay. So the right answer is one is optimized. Okay, one is optimized. So Abhilash and Chaitanya says two. So just listen to this. So let's say I have a 10 GB file which I have loaded. After filtering, let's say it become to 7 GB. Then I'm grouping on this 7 GB file. If you compare here, I have a 10 GB file. I have grouped that 10 GB file. After grouping, I'm then filtering. So what is happening is it has to group the entire 10 GB. Grouping is expensive, right? Grouping is an expensive job, right? It is going to every row and creating a bag of every tuple inside that relation. If you remember the grouping operator, right? So grouping is very expensive. If you filter first and then group, so it has to group on less data. If you filter later, ultimately you're not using it because you're filtering it later. Okay, so the first is optimized as it is grouping on less data. The best part with pig is either you write the first flow or the second flow. Pig will always run the most optimized way. Pig will automatically optimize your logic. Even if you write the second way, pig will filter first and then group. Okay, how pig is able to do it? Because if you remember, pig is creating a plan for every statement. Okay, as soon as it gets the dump or the store statement, it will optimize the plan because it knows the entire data flow now. Correct? It will optimize your plan and then trigger it. Okay, and how will you make sure it has optimized or not? So if you're writing in the second way also, how will you know it is running in the first way? You can make out by looking at the explain plan of that pig. Right? You can make out by just looking at the explain plan. So again, you will not get everything from the explain plan, but at least this piece you can make out that filtering is happening first. All right. So this is a logical plan. This is a physical plan. So it's about all your, how it is processing your bags, what casting it is doing, right? And this is about your actual map reduce plan, right? So what it will be doing in the map phase. So there are more sections: map plan, reduce plan, combine plan. So it runs your combiner also, by the way, on its own. You're not defining anything. Okay, so it is in terms of, again, it is in terms of your pig language itself, but your pig is writing it. So I'm sure you'll not get everything out of this plan, but the major portions you will get. Okay. Now there's one more statement called as illustrate. Now what illustrate will do is, let's say you're writing a huge logic which involves, let's say, 10 files, and the files are very big. All right, you were not able to imagine how the final output will look like. Okay, let's say you have written logic from a equal to b equal to c equal to until you have gone to, let's say, I equal to. There are lots of steps in your statement, in your entire pig code. You're not able to imagine how this final I will look like. Right? Now, if you want to see how it will look like, what you will do, you will say dump I. What this dump I will do, it will process everything. And if your logic is very huge, it will trigger lots of map reduce jobs. It will take a lot of time to just see what the output would be. In this case, you will use an operator called as illustrate. What this illustrate will do is, it will again run a map reduce job, but it will run on a very small subset of your data. Okay, so what illustrate does basically is, okay, it will just run on a very small subset of data to, so you would be able to just imagine how the output should look like. So this would be an actual output, but not the whole thing, a small part. So this will again trigger a map reduce job, but on small subset, so our output would be faster. Okay, let's say based on what is obtained in I want to design my remaining steps. Right? In such cases, you can use illustrate. And if you know if your file is not very huge, okay, if you want to check the entire data, you can simply dump I. Right? Yeah, so Rahul says it's an awesome feature. Yes, it is. But Rahul, my usual experience is illustrate. So let's say I have a huge data, and the actual thing I wanted to imagine is that particular row which is coming at the very end of my file. So illustrate will just pick up any random piece of data and give you an illustration. Okay, it may skip what actually I wanted. Getting it? So it may skip that particular data because it's a random piece, it's running on random data. Okay, so I usually don't use illustrate personally. I use dump. Okay, it gives me the entire thing. If I want to limit my data, I can use a limit operator. Okay, let's say my output is 1 million records, I can limit it to 10. Just I can print the top 10 or something like that. So it's a good feature, I agree, but sometimes it fails. Okay, fails as in not in terms of processing, in terms of what output you want in terms of that. Okay, let's come out to the demo. Let's now try to execute pig. All right. So it's already 11:15. Do you mind taking a 10 minutes break and then we start with a demo, or should we started right away? Okay. So I have mixed answers. Let's do one thing. Let's take a 5-minute break. Okay. Let's take a 5-minute break and then let's start. Okay. 5 to 6 minutes break. All right. All right, guys. See you in 5 minutes. All right, guys. I hope everyone is back. So let's start with a demo. Okay, so I'll be showing you two pig scripts. Okay, that's based on the healthcare data and the weather data. Okay, so I'll just close off these, not required. Okay, now if you look at healthcare data, so we have seen this earlier, right? The same use case. I have personal healthcare information about my patients. I want to encrypt a few fields. The same use case, which we have done earlier using MapReduce, we will do the same thing using pig. All right. So I have my healthcare data. I have two CSV files. Let me open it in Notepad++. Yeah. So I have a CSV file. So my patient information, my name, ID, gender, email ID, okay, everything, disease. Okay. So what I'll be doing is some of the fields I would be encrypting. Now for encrypting, so we'll take an example where I'm writing a UDF for encrypting. Now encrypting is such a thing which Pig will definitely not provide a method to encrypt, right? It's a customized method for encryption. So what I'll be doing is I'll be writing a Java code. Now this is my Java code. Very simple Java code. See the method which I have used for encryption. Okay, so in case of MapReduce, right? I have already implemented how to encrypt, right? Same method I'm just copy pasting from there to here. So this is my encrypt method, right? It takes a string which needs to be encrypted and it takes a key, right? So remember initially I was passing a key, for example, sample1234, any key which on the basis of which it should encrypt, and the same key should be used for decryption also. So that key I will be passing it. So this encrypt method will return me the encrypted string. Now what I'm doing in my actual code. So I've written an eval function. I've written a UDF, de-identify UDF. I've written extended it from an eval function. I'm overriding the exec method. I am, okay, this input is a tuple, right? I'm getting the field from this tuple. I'm passing that field to the encrypt method. Okay, and whatever this encrypt is returning me, I am returning out from this particular method. Okay, so to this uh, to this UDF, you will be passing a field which you need to encrypt, correct? Along that field, you will be passing a key also, on which key I need to encrypt. So basically you would be passing a tuple to this particular method which has two fields. The first field would be the string which you need to encrypt, and the second field would be the key which on the basis of which your data should be, the string should be encrypted, right? So it will get the first field, this is a tuple, tuple.get0 will return this string, tuple.get1 will return this key, right? I'm passing both of these to my encrypt method. Whatever string I'm getting from this encrypt method, I'm returning out of my exec method. That's my UDF method. That's it. It's very simple. If you see, it's hardly a 3-line code. If I consider this encrypt method to be a utility method, it's hardly a 3-line code, right? I have already created a jar of this code, right? I've already created a jar. So this is my jar, right? Now let's see the execution. So let me first place this entire things to the Edureka's VM. Right, so I've put everything to the Edureka's VM. It's still transferring to a queued. Why it is taking time? Okay, the files are huge, that's why it's taking time to transfer. Yeah, done. So what I'll be doing is I'll be placing these two input files on my HDFS. Okay, this is my input file 1. So I'll say Hadoop fs-put this file to my user at Eureka Hardeep folder. I will place it with the name pig input 1. I will place the second file with the name pig input 2. This is my second file. Right, done. Now what I will do is I will enter into pig. So when I just say pig and enter, it by default runs in MapReduce mode. Okay, so if you look at the logs, see it is connecting to Hadoop file system. It connected to HDFS. It connected to Hadoop. All right. Now the first syntax, what it would be, the first statement. The first statement is I would be registering this jar. Yeah, actually, yeah, the first statement should be load. As I'm using a UDF, the first thing is I'll be registering my jar. So I'll just say register and this jar name, which is already there with me. This is decrypt.jar. So it's home at Eureka. This is a local path. So it has been, oh, it says does not exist. Oh, it should be a slash. Yes. So if you notice, so when I just say pig and enter, it entered into grunt. So this is grunt is basically the execution shell of pig. It's called, this environment is called as grunt. And the language in which you would be writing inside this grunt would be pig Latin. Right? So it has registered my jar. If I exit from my grunt and re-enter, so this jar I need to re-register again because the lifespan is just until this session. Okay. Now what I'll be doing is, so I have a script already written. I would be executing it line by line. All right. So I will load my healthcare data set. Now it's a comma separated. It's a CSV file. And this is all the fields inside that data. So I'm defining a schema. All right. So I'll just update this path. Now this path is, it's there in my user at Eureka. Hardeep big input 1. Right. So I'm just saying load. I've given this path using pig storage and I've specified comma because it's a comma delimited file as, which is an optional step, and I'm defining my schema. So this file is very huge. It has lots of columns. So it's better to define a schema. So let's run this. Okay, so Abhilash's file name needs correction. Oh. All right, so I had executed it previously with a different name. Very interesting thing to note. My command didn't give me any error. There is no error. This path does not exist, but still there is no error. The reason for this is pig did not execute this. Pig just compiled it. It didn't even go to your file to check is the file exist or not. For example, if I say a equal to load any path which does not even exist. See, no errors. The reason is pig is not even going and checking the path. When it will face an error, when I will actually trigger a map reduce on this. And how will I do it? I'll say dump a. Now it will trigger a map reduce job. Now it says input path does not exist. If you check the error, input path does not exist here. Right? So I'll just run it again. So if you run again and again using the same left hand side, it will override the previous. So initially I had run this a equal to something. I'm again running it with a different path. It will override the previous one. Again, the left hand side which we are seeing, the relations basically, their lifetime is the scope of these relations are also till my session. My session finishes, I won't find this a again. All right. So I've loaded my data in my a relation. Now, if you want to just check it's loaded or not, I can dump a. Now it will trigger a map reduce job, read the file. So the best part with pig is after every step, whatever the output is, you can check the output using this dump operator. See my output. It's a huge file, that's why it's going on printing. I did not limit my data. I'll just use a control C. Okay, so if you see, it's a tuple, right? Inside a parenthesis. Okay, so again re-enter into pig. I will register first. I will load, done. I will follow the next statements. So I have two files. I'm loading both these files. Right, both the files are loaded in A and B respectively. I'm doing a union, right? I want to run on both of these. I'm just doing a union A and B. Okay, if you just want to check if it has done a union or not, you can dump C and check. See, it's not always required to dump at every statement. It is just if you want to check the data structure. Okay, and not at every statement you won't say dump. You will define the entire flow, and the last relation you will say dump. So in this case, if I dump C, it will execute the plan for A and B also, even if I'm not dumping A and B. So that's a beauty. It will basically, that's the beauty, right? That's the thing which I was telling about the plan. If you dump C, it will see C is using A and B. It'll go to A and B, check the plan, create a plan, make it physical, and execute. Okay, so Shiv says limit the rows to see the output. Okay, so I will dump C. And I will say limit, I'll say 10. So it will display the first 10. Okay, so until this is running. So let's see what I'm doing. Okay, so for every record in this C, right, I'm generating what I want as my final output. Okay, so if you see patient ID, which is already there, I don't want to decrypt. I don't want to encrypt. So I'm printing it as it is. Name, I want this to be encrypted. So I'm calling my de-identify UTF, which I've written inside this char. I'm passing the name and I'm passing the key on the basis of which I want this to be encrypted. Similarly, I'm encrypting my date of birth. I'm encrypting the phone number, email address, the security number, and disease. Weight, I am not encrypting. Right? So getting this statement. So this for each generate will run on every line. Okay. So let's see the output of the previous statement. It gave an error. It is not limiting. So I've not used this since long. I'll just quickly check it. Oh, got it. So I'll register first. I will load A. I will load B. I will do a union. I'll say limit C10. Okay, I need to take it inside a variable, so I'll say d equal to, and I'll say dump d. Right? So see, it has printed the first 10. So this is a syntax of limit. It's it's not a usual thing which we use. That's why we can simply look up on the net and check what's the syntax. Okay. So next thing is I'm using my UDF. Okay. And that's my final output. D is my final output. So I can do two things with my D. Either I can dump. Okay. So as we have seen dump displays on the console, my file is very huge. I should not dump. So I will use store. I will say store D into, I'll give a HDFS path. So I'll say user Edureka deep pig output 1. Right. So as soon as you say store, it will again trigger. So there are two triggers, dump and store. So until this is running, overall, how do you think pig is simple, difficult, how it is? It's just like any other language. Yeah, it is simple and interesting. So Minesh, do you think it's difficult? Oh, so you're comparing it with SQL. No, it is not SQL. So you will, if you're comparing it with SQL, Hive would be very simple for you then. Right? Hive is the one you're looking for. Rahul says map reduce word count we can't do in pig. Rahul, we can, because pig can work with unstructured data also, right? So in fact, map reduce of pig is hardly 5 to 6 lines. That's it. Right? We can do map word count in pig also. We cannot do it in Hive, but in pig, as it can work with unstructured data, we can do map reduce. We can do word count. So Bhaskar says, in general, what are all the ecosystem components you use in your day-to-day operations? Okay, so Bhaskar, we usually use Hive the most. We use Impala. We have just started using Spark SQL. Right? Most used is Impala actually. Impala Hive is same thing, not much difference in terms of usage. We never use Java MapReduce. We hardly use Pig. We don't use Pig. Then we extensively use other tools like your DisCP. We use Coop, right? Those things we use. Yeah, so Bhaskar, yes, Impala is also like Hive. It's just not free. It is a product of Cloudera. Okay, so Minesh says, can you show us an example of word count? Minesh, if you just Google, you'll find it. It's very standard, hardly 4 or 5 lines. All right, so I have my output. Okay, so I've stored it on, what was the path? User Edureka Hardeep pig output. So let's check this. The best part is from within Grunt, you can query your file system. Right? So I'll say fs -ls. You don't have to write Hadoop fs. If you're doing it from Grunt, you don't have to write Hadoop fs. fs-ls. So it would be just, see, it has created two part files, and this, if you notice, it's a part M file. It's a mapper output. Right? See, I'm doing it on per row, right? I'm encrypting my data per row. I don't require a reducer. I'm not doing my reduce function. So pig is very intelligent. Pig knows reducer is not required. So the file name is a part M file. Right? I will just print a few rows of this file. I won't print this entire file. I'll say fs-head. I'll print this file. Does tail works? Yeah. So I've printed the last 5 lines. So see, if you let's see this. So this is my ID, patient ID, which I have not encrypted. All the remaining fields I have encrypted, and the last field, which is weight, that is also I have not encrypted. If you just check my script, I've encrypted I have not encrypted patient ID and weight. Remaining all I have encrypted. This is what is my final output. If you need to do it in Java, imagine you would be writing a mapper, driver, package to a jar, okay, run it on the cluster. It's a long process. In Pig, how much time it took? 1, 2, 3, 4, a 5-step process, 5 statements, and it's done. Right? That's the best part with Pig. Okay, similarly, there's one more example. So I have my weather data. This is my weather data. Oh, so Bhaskar says how much time you would want. Okay, so Bhaskar, just 5 minutes, not much. Okay, so this is my weather data. 1, 2, 3, 4, 5. This 6th field is my maximum temperature. 7th field is my minimum temperature per year. This file we have seen earlier. So what I'll be doing is I'll be calculating the hottest day. I'll be calculating hot days and cold days. And how I'm categorizing hot and cold days. So I would say all the days which has temperature more than 25 degrees are hot days, and which are less than 0 degrees are cold days. So what I'll be doing is I'll be loading this weather data. All right. From this weather data, I would be substringing, and I will be getting these fields. I'll be getting these fields. Right? I will be getting this from substring. So if you notice, we have introduced one more UDF, one more function, substring. Where it's gone. Okay, I'll be using substring. Okay, I'll be storing my output to a particular location. Okay, so I'll be, instead of explaining it the entire thing, let me execute it one by one. So I'll be placing this weather information also on my HDFS. So from local to Edureka VM. I'll be just quitting from my grunt for now, coming back to shell. Weather pig. This is my file. I'll put this to HDFS. All right. I would enter back to pig. I will say a equal to load. I will load this weather data. Let me define the schema. Okay. So let me do one thing. Let me not define a schema now. I haven't defined a schema. If I describe this, it says schema for A is unknown. If I define a schema, and if I again describe A, see, it is giving me the description, just like your normal SQL, normal database. Right? Let me not define a schema. Okay. So basically, the entire row would be my data because I haven't defined any delimiter also. Okay. Now what I'm doing is, so the second statement, I am substringing and I'm getting only the specific fields, the max temperature and min temperature. So I'm getting my max temperature and min temperature. So I'm saying, yeah, max temperature and min temperature. And this third thing is year, I guess. I think it should be. Okay, let's run and see. Yeah, that's the year. The first thing is year, then max and min. Okay, it gives me an error. Yeah, so this error is I'm using data, but I haven't defined data in my schema, right? So wherever there is a data, I would be substituting that with a $0. Remember the positional notations. I haven't defined schema, as well as not able to find data. All right. So what I have done in my second case, I have substringed, and I'll be storing this output at a particular location. So I'll say store AF into user Dureka Hardeep. Let's say temp. I'll store it in a temp location. Okay. So from the very huge file which contains so many fields, I have just removed year, min temperature, max temperature. I have placed it in a separate file. And from this file onwards, I'll be calculating hot and cold days. Okay, executed. Let's quickly check it. fs minus tail user Dureka. All right, so it is ran successfully. And if you notice one more thing, I'm storing it. Yeah. Okay, so in this case, right, I haven't used using pick storage comma. So if you notice, by default, it is stored by the default delimiter. That's a tab. That's the between spaces are tab. So my file I haven't used using pick storage in my statement. I just use storage into a location. So it used the default delimiter. Now I say, I again load this in a particular, I load this particular file into one more alias. So I'll say anything. I'll say data equal to and I'll specify the schema, date, min, max. I'm not specifying using static storage comma because that's a default tab itself. Done. I'll say min temp equal to filter data by min less than 0. Okay, so it's very similar to SQL, right? Filter data by min. What is min? Min is this min I have defined in my schema. If I haven't defined schema, I would say this as $1. Both will work. $1 less than 0. Okay, both will work. And I'll just dump min temp. Right. Similarly, we can do it for max temp also. Right. So if this output is here, so we would be stopping for today. Right. So if you see, all the temperatures are less than 0. All the temperatures are in minus. All right. All right, guys. So let's stop for today. Okay. Have a good night. So tomorrow we'll be starting with Hive. Right. Hope you got what pig is. Okay. In case you have any questions, any doubts, you can come back to me tomorrow. All right, guys. Thank you very much. Please don't forget to fill in the surveys. Okay, give your honest feedbacks. So tomorrow we'll be starting with Hive. Okay, so if you understood Pig, Hive is very simple, and I hope everyone knows SQL. So Hive is pretty simple. In terms of language, it is very simple. In terms what it does in the backend, that's your MapReduce. So ideally, you know both the things. Tomorrow we will just stitch it together. Okay. Thank you everyone. Have a good night.